so my name is Matt, and there's my Twitter handle, and I am a co-founder of the website thinkster.io, where you can go and learn about Angular or MeanStack or whatever. Rather than plug that, though, I'm actually going to shamelessly plug two of my friends' book. Diego and Val wrote a book, and it's coming out sometime soon, so buy it. They tell me it's good. I haven't seen it. All right. So what is Mongo? Mongo is a NoSQL database. It is open source and is developed by a company called MongoDB, formerly Tengen. It is a document store database, which essentially, as Ward mentioned, is very similar to JSON objects. And it doesn't have a set schema, which really makes it just incredibly easy to manage and maintain. Why would you use Mongo, and why does it work with the MeanStack? Well, it offers a substantial amount of flexibility, especially over your typical relational database style. So it's really good for unstructured data. It does complement Node's goal of a JavaScript stack through and through, especially with the MeanStack, since storing data is very much like storing JSON objects. And it also has a lot of really cool advanced querying features like MapReduce and geoquerying. So there are two big concepts to know about MongoDB. One are there are collections, and collections are akin to tables in SQL, traditional SQL. They contain documents, and you run queries on collections. Now we have documents. Documents are very similar to rows in SQL. They're queryable, and they can be nested, as Word demonstrated. Well, I guess close to it. Updates on documents are atomic, and they have a set limit of about 16 megabytes. So to begin with, we'll go ahead and install, in quotes, our MongoDB driver in Node. So we'll do an npm install --save, and what this will do is write to the package.json file. So in the future, we'll be able to do an npm install and then have our Mongo driver just pop up. It'll be really great. Here's some code that looks like for connecting to the MongoDB from within our Node server. Pretty simple, pretty self-explanatory. You get you call a connect function, and you get a callback that has the database object. Now, typically what you want to do is you want to reuse the same connection for your entire Node application. And then you can also do connection pooling with it. And unfortunately, requiring the DB objects with a native Mongo driver is actually fairly difficult, since it needs to be initialized synchronously with the Express app. We do have an example on the Express or on the GitHub repository, so you can go ahead and check that out if you're interested in doing it. There's also a substantial number of third-party Mongo libraries that will take care of this for you. For this presentation, though, we'll be using the native Mongo driver. And now on to the live coding portion of this. So, and that's not what I wanted to show. All right. So you can make this bigger. OK. You guys all see this? Try to make this work out. All right. So picking up where Ward left off, we have a file that has all our functions, and these are exported, and then they are hooked into routes. So this is hooked into our /API route, and we're going to fill out these functions now. So to begin with, the first thing that you typically want to do is you're going to want to create like an index route. And the first thing you want to do is return a list of all questions that might be in the database. So to do this, we start by creating a query object. And I should note that we have this object called questions, which essentially is a collection object. As I mentioned about collections, there are a series of documents. And we're going to call a find query on the collection object, like this. Now, what this does is this actually doesn't go out to the database just yet. And we can modify this query in several different ways. And hopefully, we'll get to being able to do that later on in the talk. For now, though, we're just going to call query.toArray here. And what this does is this actually instructs the Node program to go out to the database and query for the questions. Now, as Ward mentioned, we want to have our error handle. So if we have an error, we'll go ahead and throw it next. Otherwise, we're just going to send back the questions to the user. Ward already explained to you guys Postman, so I will be using that in this demonstration. Here we have a route. I don't know if you guys can see this. Hopefully you can, because I can't make it bigger. So anyways, we're going to go ahead and send that. And you'll see that we're now getting 3 questions back, which have been pre-populated in our database. And this is all working. Awesome. Next up, we're going to have our get singular question by ID. Now, for using this function, we're going to go ahead and do it by using a method on the Mongo driver called find1. Pretty simple. And it operates on collections, as we mentioned. By the way, the syntax for creating a new collection is just like this. So what this does is this creates a new DB collection on the questions collection. So we'll call find1 here. And what we'll do now is we're going to pass in an object ID. Now, as Ward mentioned, talk a little bit more about object IDs here. The object ID is a 12-byte BISON type, and BISON is the JSON format, essentially, that MongoDB uses natively. The object ID specifically is guaranteed pretty much to be unique. The first 4 bytes are a timestamp that represent milliseconds since the epoch or seconds since the epoch, and then there's a 3-byte machine identifier, a 2-byte process ID, and then just a 3-byte random count. The underscore ID field is very similar to the ID field that's typically created in SQL databases, so it's very good to query on. So going back to this, go back here and do the same function with our callback and with, about that one, error there, and then we can also do, again, not that one, res.json and send a question back. Now, if we go back to our postman, we now have this get question by ID route. And this is a string formation of the BISON object, or I'm sorry, the ID object. And we can go ahead and search for this guy here. And now we have this question that's returned. You can see we have 4 votes associated with it, a name associated with it, and then some text. All right, so now we can retrieve some questions. So let's go ahead and figure out what it looks like to create a question. We already have some code here, and what this is going to do is it's going to take the information from the post request and parse it out into a text field that we're going to use to go ahead and insert information. So the first thing to do is to create a JavaScript hash that has our question. So you'll see here we're creating a new date time, or a new date to, for now, and then the text, obviously, and then the name of the person who asked the question. And then we'll also have a vote count, and we're going to start off with 0. Now what we're going to call is we're going to call the insert method on the questions collection again. And we'll just pass in the question variable and call our callback function. All right. So now if we go back to the postman route, we have a sample question that we're going to create. What are this? We'll go ahead and click the send button. And as you can see, this thing has been returned back. And what this means is that this has been successfully saved to the database. Now, MongoDB also has a very nice REPL. I'm going to make this bigger. And this is kind of what the console looks like. So if we query for the collection, we can call it db.questions, and then call the find method here, and then pass in a blank query so we get all of them back. And we'll actually do a .pretty method, which will make this nice. We can see now that the question we just created has been actually successfully added, if you guys can see that. Oh. There you guys go. Top. So we know it's been actually accessed and entered in the database. And we can also, again, confirm this by calling our index method, which returns all 4 questions that we have. Sweet. All right. Now for the fun part. So this is where we do an upvote, or we initiate the upvote route for our questions. So this allows people to be able to vote a question up or down. We're not going to restrain them necessarily by the number of votes they could have, though our web interface will probably stop them from doing it. Right now, as you can see, we're just parsing out the vote from the query parameters. And then we're going to call this function called find and modify. And I want to talk a little bit about this. This is a little different from a typical MongoDB call, which would be the update command. The update command we could use, however, it does not return the question itself back. It's kind of a fire and release. So we won't be able to get the question back, and we won't be able to return it back to our front end, which is a requirement of the front end. So to begin with, we will search for the ID. All right. Now, the second parameter of this thing is actually interesting. It's a sorting parameter, and this allows us, Mongo, to sort the objects. So because we're querying by unique ID right now, this is not too important. But if we were, say, to query by an author, we could sort them according to a different field and then only update the first one that are in the list. Now, the second part is actually going to be our update parameter. And Mongo has this function called increment, which allows us to atomically increment any variable inside of the document. So the syntax for this is going to look something like this. So we have our vote count variable, or our vote count, excuse me, field inside of the document. And we can update it by the vote amount. Finally, we have an options field. And the only option we care about for this particular example is new true. By default, what Mongo is going to do is it's actually going to send off the question, the update question, and then return back a question before it was updated. By specifying the new equals true, we're actually going to be able to get the updated document back. And then finally, of course, as always, the callback. All right. So now if we go to our Postman client, again, I hope you guys can see that, we can upvote a question, theoretically. Yep, syntax errors. All right, let's try this again. There we go. All right, so now we have a vote count of 5. If we press this again, it's just going to constantly increment. 7, 8, 9, etc. We can even go over here and we can upvote it by 3. So if we send this, now 12, it's going to go to 15 afterwards. And this is all, again, saved back to the database. If we'd like, we can also decrement it by 1. Fantastic, 13, 12. So that's all working. All right, and then the final portion of a typical CRUD application is you want to make sure you can delete comments. So to do this, we're going to use the find and remove function of MongoDB. And again, what this looks like is just dot find and remove. Search by the ID, and then pass the function that'll take the question back. So if we'd like to, we can not return the function, or I'm sorry, not return the question. However, and that would be the remove command in Mongo. The find and remove command will actually go search for the document and then remove the document and return it back to our client so we can check to see if it was successfully removed. So as always, have the error function. Now, because of this, the only way that we know that the function has been, or that the question has actually been removed is if the question has been returned. If no question is returned and there's no error, then we know that there wasn't actually a question. So we're going to check to see if the question exists. And if it does exist, we're going to go ahead and do a res.status of a 204, which is going to be defined in our API spec, and then just .end, which will send a blank body back. Now, if there was no question, then we have this function here that will throw an error automatically and let the user know. Now, in the Postman, we'll go here and test out our delete route. So if we click the delete button on this question, we see that no content was returned, but there's a 204 status, which means that our function completed successfully. If we try and press this button again, we're going to get the error message, question not found, which means that, again, everything is working perfectly fine. All right, so this is typically the point when you might be able to have like a prototype, you have a demo, you deploy it, you have some people upvoting it, and it's great. Everything's going fine, you've got a live system. However, we've all probably been here when a new requirement has appeared, right? And your boss is going to come to you and he's going to go ahead and say like, hey, you know what would be awesome is like, we would really like you to just be able to classify these things by categories. Also, it would be just super swell if you could keep track of the individual votes and when they were actually submitted. And you're like, man, I already got this in production. I don't necessarily want to do any sort of database migration or muck with that. Fortunately, with MongoDB, you don't have to. So we're going to go back up to our vote for question, or actually we're going to go back up to our create question first, and we're going to go ahead and when you create a new question, we're going to add 2 new fields here. The first one is going to be a category, if you guys can see this. All right. First one's going to be a category, and then the second one is going to be the array of votes that Ward was talking about previously. And what this vote, the array of votes does is it actually creates a bunch of sub-documents that are going to be associated and nested inside of the original Mongo database document. This also allows for things like atomic operations inside of the sub-documents, which is really, really powerful. Now, if we go back and we check our create post route, and we try and add a new question, hit the send button. And like Ward, we forget to save. All right, try this again. And now we have a returned with a category of express. And we have an empty array that represents the empty sub-documents that have been nested inside of our document. All right. Now we go to our update vote, or our upvote method function. And what this one is actually going to look like is now we use this function that's built into Mongo called the push, which, as you can probably guess, pushes a sub-document onto a document array. So the document field is votes, and we'll push a sub-document called votes onto this function or the array. and it'll just be very, very simple. We'll include the vote count, which will be like 1, 3, -1, whatever you want, and then also a time. A time of when the vote was actually submitted. So now if we go back to Postman and we want to update the vote by 3, we now have this function that returns, and we now have our votes associated in the subdocument. We can of course change this, make it like 100. And we now have 3, 100, and then the vote count has been incremented accordingly. And what's really, really powerful is, again, we did not have to do anything at the database level. We did not have to migrate any tables or create any tables. We did not have to add any rows to it. Right? All we did was just tell Mongo we wanted to insert these fields, and then it let us do that. All right. So we're going to go back up now to our index method, and we're going to add paging. And paging is obviously something that's pretty cool, and it typically requires 2 sorts of functions. You need to be able to limit the amount of questions that it returns, and you need to be able to skip a certain number of questions so that you can load the first 10, the second 10, the third 10, etc. So to do this, we are going to use a function that was previously written called getQueryOptions. All right. And what this function is going to do is it's just pretty simple. It'll just parse out what the limit is and what the skip is if it exists. Now, one of the really cool things about Mongo is that you can assemble queries on the go. So you create this query object, and as I mentioned, it does not actually go back, and it does not actually create the query until we call the toArray function. So now that we have this object, we can continue to limit it, skip it, and later on we'll show how to sort it as well. So now if we go back and we add a query parameter to our getAllQuestions, we can now limit it to 2 questions that we want to return. And you'll see here that only 2 questions have been returned. If we want to skip or offset by 2, we can do that as well. And we now have 2 questions, but both of these are going to be completely different than the previous 2. By default, Mongo sorts by the ID, which typically is time inserted because of the timestamp built into the _ID field. All right. And then finally, we can also add sorting. And what the sorting looks like is it actually looks like this object right here. Right? And what we essentially have is we can sort by vote count, and -1 is decreasing. And pretty much what that means is obviously the top vote or the most upvoted question will appear first. We can also sort by time created. So this will be the most recent or least recent question first. And we can go back to our Postman route, and we can test this as well. So now if we go here and we specify votes or vote, these things are going to appear in descending order of vote count. So 115 there, we've got 2 here, and then 0 and 0. All right. Now finally, one last feature of MongoDB that I want to show you guys is something called projections. Now, something that's a typical situation is that documents can get very, very big, and they can have a lot of fields. And for certain queries, you might only want to retrieve certain fields. You might only care about, for example, the name or the text. You might not care about the nested array of votes, but maybe just the vote number. So what we can use is we can use a Mongo database projection in order to only retrieve the fields that we actually care about. So what we'll do is we'll have this object called fields, and what we're specifying is 1 next to the fields that we want retrieved. You'll note that the votes array is not specified there, so when we complete this query, it will not actually be returned. Now, this fields array can be added to multiple different queries. We will just be doing it with the find one, and then as always, call the toArray function on it, right? All right. And now, if we go back to the Postman client, and we call it with the projection operator, you'll note that we're returning a list of arrays, or a list of questions, but none of the subdocuments have been returned because we did not specify that in our projection. All right. That about actually wraps up the MongoDB portion of this. I was instructed by MongoDB. If you guys want to learn more about them, they have another event that's happening December 3rd. It's a meetup in San Francisco. Come learn about it. And then finally, we have, right now, we have the live demo that's up. There's the link to it. We're about to take a break, so feel free to go here, upvote, vote on questions, upvote questions. And then Alicia will be up after the break to explain what the front end looks like and how we built it. So thank you guys very much.
Thank you.
Well done to you.